Intel live stream here. How's everybody doing? Oh, maybe I didn't unmute myself. Thank you for whichever mod did that. Shout out to the mods, DJ Marlis and Scave for joining us. Thank you, thank you. How's everybody doing out there? I've got Ambrose the dog here with me today. He's busy working on a bone, but now that I've started talking, he wants to know what's up. Hey, Misha 3D. Hey, Foob0815. Hey, Star Fox. Hey, Springer. Welcome, welcome. Oh, now he's decided that he's going to be a pest, I think. Go lay down. Go lay down. Come here. He has a bone that I did not give him. I don't know where this came from, but he's busy working on it. Go lay down. Go lay down. Go lay down. Hopefully that satisfies him. If not, I'll kick him out. Hey, Centella. How's everybody doing out there? So, we haven't had many, and by many, I mean any, submissions this week. So if you would like to show something off on today's show and tell, I would encourage you to go sign up. It can be super low key. It doesn't have to be anything super fancy. You don't need any fancy equipment. You just need a phone or a webcam. It's all in your browser. So go here to fill out a little form. Let us know that you want to show something off, and we'll get you on here. Otherwise, this is going to be pretty low key. For some reason, I got signed out of a bunch of things. I'm going to sign back in. Slightly weird. Let's see if I can do this without showing off my password here or anything like this. Say that because I've done that before. Twice even, I think. Let's see. It is weird I got logged off right as I was starting the stream here. All right. It's back online. I'm just getting a few things set up here. Okay. Yeah, my Google account got logged out, which a bunch of things are based on here. All right. I need to set up a good IRL stream setup. Yeah, I've been thinking about that. Yeah, it's a whole project. Just do it right. To do it right. I honestly, I have worked pretty hard even just to get a shop streaming setup here, and it could be even better. Right now, because I'm up in the mountains, there isn't fiber here, and there isn't cable. So I'm on wireless links, and I've actually got redundant links. I've got point-to-point wireless across the valley, which is in theory 100 symmetric. But we, like for instance, the other day we had big wind and it blew the dish sideways, and I had to get someone out to come and recalibrate it. So I've also got Starlink, and then I'm running connection bonding across the two using Speedify to a dedicated server to load balance and do seamless handoff in case anything drops during a stream. So not cheap, but worth it. So, yeah. Escape Rat says, "Who needs a live stream to leak passwords when you have it as a service as LastPass?" Yeah, I was using LastPass, and yeah, I've even had them as a sponsor, and was really happy until I heard exactly how bad their security practices are. So that sucks. If you're using LastPass still, you should seriously reconsider it. And I've actually gone through and changed all of my important passwords because they were not using the level of cryptography they should have been. So, and they got hacked, and all the encrypted password databases got leaked. So, not great. Yeah. Yeah, in terms of setting up like an IRL stream and stuff. Yeah. I mean, it's not an immediate thing that I need. I don't have a lot of places that I would go outside the shop where I would live stream. But I appreciate the advice here on all these things. Maybe when I go back, when I start traveling more, do factory tours and go back to China and stuff, we'll look into it. It's hard within China too, for obvious reasons. I looked into it there and did a little bit of live streaming out and about, but there's a variety of things that make it complicated. Obviously, like internet connections, tricky for a variety of reasons, as well as it's not something I feel comfortable doing inside the markets because I can't control what's going to happen in front of the camera, and I don't want to show something that might get someone in trouble on a live stream. So outside or like in a factory where they're cool with it, it's totally fine. But the markets, I need a little bit more of a censorship window, if you. Come here, dog. He's gonna bark some more here, probably. Might have to send him inside. Yeah. Hey, Moaz. Saying hi to Misho's son here. Glad to have you join us. Well, welcome to the Strange Rights live stream. So, I was kind of... No. What, are you bored? Are you just... I'm excited, therefore you're excited. I don't know if you all can see him. I hope where they can see you. Oh, well, that was enthusiastic. Hi. Oh, we're wrestling. I see. If you didn't see my live streams from when I was living in New Mexico, this was a regular. Oh, shush. You're being too loud. Sit. Can you show them how you whisper? Whisper. No, too loud. Whisper. Yeah, good boy. Whisper. Yes, good boy. We're working on whisper. His bark is so loud that it really scares people. And it's just because he's a loud dog. He's got a loud bark. Okay. This is not going to work. I thought he was going to chill, but I don't think so. Give me a minute. I'll be back. Give me a minute. You're being too loud. You're being too loud? No, sit. I'll be right back. You're too loud. Yes, make sure to exhaust Ambrose's energy beforehand. Yeah, I've done that in the past, and I've stopped doing that, and apparently that is required. He was calm all through half hour, 45 minutes of me getting set up here, and is calm no longer. I just realized I set back my tea down somewhere. I don't know where I left it. Hang on. Evaporated, cup and all. I don't know what I did with it. Apologies. All right, so no tea either. This is a little seat of my pants stream today. Yeah, I don't know. I had a nice cup of lion's mane tea that must have left inside. I don't know. Yeah. Well, thank you, CyberConnect. Yeah, it's good to be back in front of the camera and working on new stuff. I wish I could show you guys what I'm working on. I have leaked what I'm looking on to Patreon supporters. So if you'd like to go check it out, you can go check it out here on Patreon. But yeah, I'm working on 2 big projects right now that are iPhone related, and they're kicking my butt. So yeah, I have bought a lot of expensive iPhones in the past month, which is a little painful, but I'm hoping to have a breakthrough soon here. Got 3 varieties of current iPhones sitting right here, so in various states of not working, which is definitely frustrating. So I wish I could show that stuff off, but I'm not quite ready to show that off to a fully public audience. So if you want to go check it out on Patreon, you can do that. That's not me just trying to push Patreon, though it is a huge support right now, as I'm still ramping things back up and I'm trying to hire people. So it really is the best way to support me. But it's not a Patreon pitch. It is me trying to be a little secretive about what I'm working on. Yeah, so I'm struggling a little bit for what I can show off today, since we don't have any folks signing up. But if you'd like to sign up to be on the stream with me, please do so. Yeah, states of not working just means engaging challenges to get working. But yeah, it's going to make for a good story. I actually had a phone shipped to me from out of the country, and I got stuck in customs for more than a week. They required some paperwork, and I sent them the paperwork, and then they said I didn't fill out one field, and they sent me the paperwork again. It was a whole thing. There's an interesting racket that runs between Apple and U.S. Customs and Border Patrol, where Apple basically has told Customs to seize anything that has an Apple logo on it. And I was a little bit worried. This was a brand new phone that was still in the box. And I was worried that they would actually just seize it and destroy it. But they didn't. They sent it on to me. And then I thought I was going to get a bill for import duty, which I think I should, but I haven't gotten that yet. So we'll see what happens here. Yeah, this was my backup plan, graphics gear. Yeah, that was, it's good to see you, by the way, on the stream here. But yeah, my backup plan was to fly up and get one. And it, as expensive it would have been if they had seized a $1,000 phone and destroyed it, it would have made for a good story. So I could have blown that up. So, it's not everything. When I'm making videos, not everything that initially appears bad is actually a direct problem. But it sometimes makes stuff take longer. So, yeah, I mean, it's this trade-off between I don't want projects to be too easy, because then there's not really a story. It's just like, well, I did a thing. And I don't want them to be too hard, because then they take forever. I want that sweet spot where they're hard enough that it's a good story, but that they're not too expensive in terms of time and money. So it's a real balancing act here. Oh yeah, let's definitely make that account a mod, graphics gear. I didn't realize you weren't. Let me handle that real quick here. While I'm doing that, let me see what's in another tab. My secure gift says I'm working on a fiber to the home project design for your local community. That's awesome. I'd actually love to hear about that. If you want to come on the stream and talk about that, that would be awesome. Or if you want to provide more info in the chat, that works too. Yeah, I'm very curious about like community fiber to the home projects, because I'm looking at buying land here somewhere in the area that I'm currently at. I'm renting this current space, and I want to get into a forever home here. So I'm very curious about that because there isn't a lot of fiber in the area. There is some fiber going in across the way, but it's very limited. So yeah, let's see. Let me get logged in here so I can mod graphics gear. In case y'all don't know, graphics gear is also goes by Nosh, and Nosh has been our lead moderator here at Strange Parts, and he's been fantastic. He's helped grow the moderation team and train everybody up, and train me up in how to work with moderators, and has been a fantastic person in helping make these live streams run smoothly and the Discord run smoothly and all of that. So hugely thankful. How do I always forget where to go in Twitch to do these things. Think about it. Roles manager. Spell your name correctly though, graphics gear. Don't want to mod the wrong person. I got it. Moderator. Done. All right. You are now a mod on this account. Graphics gear. Yeah, the Louis Rossmann getting used parts confiscated was kind of what I was basing that on, and his conversation around that. It's been a problem for a long time, and I mean, I get that customs is a good way to police fake goods, right? If I make, if I make a fake iPhone shell, I've got a broken one sitting here on the desk for a project I'm working on. If I make a fake one of these and try and send it to the US, then that's probably something that customs should get involved with, because that is kind of part of their charter, right? And it's part of this whole like trademark. If nothing else, I mean, I have conflicted feelings about patents, right? Particularly for something like this, and particularly for something that's like essentially a replacement part. But at least trademark, I definitely think is pretty reasonable for customs to be enforcing. The problem is they are enforcing trademark on things that aren't necessarily fake, right? They're enforcing trademark on things that were bought legally and are being sold used. So they shouldn't be sealing that. They shouldn't be seizing that stuff. I said stealing, and that's probably actually more appropriate. I think the tricky part runs into, is this fake or is it real, right? And with a lot of the backs that I've seen in the markets, it's a challenge to tell. They're pretty close. So, I think it gets into a very blurry area. But yeah, fortunately they didn't seize my new inbox iPhones. I think it did get opened. But yeah, I mean, I had all the receipts for it and stuff, so. It was genuinely sealed, so I don't know. Making my own keyboard. Yeah, I've thought about it, for sure. I have put together a keyboard kit on stream, which was fun. Yeah, I have a keyboard project that I have in mind that I bought supplies for like a year or two ago and then never really got started with. And then I also have like a keyboard modification project that I showed off on a previous stream, taking one of those old Microsoft Natural keyboards and chopping off the number pad. So I need to work on that too. Honestly, right now, I'm just so bogged down with these iPhone projects that I'm just barely keeping my head above water. I'm trying to get a video out as soon as I can, for a variety of reasons. Obviously, you all want to see a video, but also from a sponsorship and money flow perspective, it's good to release videos on a regular basis. Obviously, Patreon's helping smooth that out a little bit, which I'm so thankful for. Thank you all for supporting me on there. But yeah, it's tricky working on these big ambitious projects and then having them go a lot poorly, more poorly than I expected. It's been a bit of a slog. So yeah, I had something that I thought was going to be pretty straightforward, and it is anything but. So yeah, I have not fully caught a phone on fire yet, but I've tried. I have a part to show. This is this is a ultra wideband antenna that is totally toasted. You can tell on the end here that it actually melted the connector off, which is problematic to say the least. Not expected either. It was actually like I was kind of done messing with the phone, and I had it sitting charging, and it showed an overheat message, and then so I just unplugged it and walked away, and I came back later and found that it had a significant amount of charring and and heat damage right next to the LiPo. And fortunately, the LiPo didn't catch on fire. Otherwise, it would have been a real problem. So, yeah. What other questions we have here? This is an interesting conversation. Louis Rossmann is a joke, just a guy who grandstands because he has a vested interest. People have always had the right to repair their stuff. Companies have always had a right not to fix shit under warranty when you don't fix it right. Yes. I mean, I'm not sure that Louis has ever advocated for companies being required to fix things that were broken when people try and repair them. That, I think, has always been the case. I think right to repair is a lot larger than that, which is, is it reasonable for companies to restrict the ability for third parties to repair things, right? Whether it be through software cryptography, pairing and locks, whether it be through making it so that parts aren't accessible, replacement parts aren't accessible, or whether it be through things like restricting access to the necessary documentation and tools to diagnose something. I think the analogy I always come back to is cars. In the U.S., we have this very deeply ingrained culture of car repair and car modification, and we don't really think anything of that. We don't talk about how someone shouldn't be able to repair their car, sitting in their driveway, or modify their car, right? And you can get repair manuals for cars. You can get spare parts both from the manufacturers and from third parties. There's a lot of accessibility, and I think if we if we tried to apply laws to cars the way we are to iPhones, and if manufacturers were doing the things that they're doing to phones, to cars, I think there'd be huge outrage. And that somehow, because a phone is sort of considered this black box, that it's reasonable to restrict it in various ways. So that's kind of my take on it. I think Louis is often outspoken, but I think he's on the right side of history here. I really think we all benefit from having some sort of minimum standard of what companies are and aren't allowed to do that might restrict people's ability to repair their own devices. And obviously I benefit from the right to repair movement. I'm definitely a supporter of the right to repair movement, but I benefit from it in that the things that you need to be able to do to repair a phone are very similar to the things that you need to do to be able to modify a phone, or any device for that matter, whether it's a phone or some other kind of device. I've done a lot on phones, but I think that that being able to modify devices is really part of what it means to own something. And if we can't repair it ourselves and we can't modify it and we can't make it ours, customize it, I don't think we really own it. So that's a big part of my motivation. Yeah, I think this kind of maps on to my feeling that nobody's asking Apple to fix something. Like, I'm not going to take, like, I clearly made a mistake on this phone that nearly caught fire, and it actually has nothing to do with the modification I was making. The antenna cable ripped, and I spent a very long time trying to repair it properly, and I thought I did a good job, and I don't think I did. I must have a short somewhere that I shouldn't. And I'm not going to take that phone back to Apple and expect them to repair it. I did order a new antenna cable in hopes that I can get it to work again, but we'll see. That's not my expectation. Nor is my expectation that that if I break something, I screw something up while trying to repair it, that Apple's on the hook. That's obviously my fault. That being said, if I make a repair, let's say I swap a battery in an iPhone and I do a decent job and I don't screw anything up, I do believe that Apple is then required to honor their warranty in other ways, provided that they can't show that it was my fault that this other thing broke. So I mean, yes, I think right to repair is asking for Apple and other manufacturers to provide replacement parts at reasonable prices. We're also asking for the ability for there to have aftermarket parts exist. But also, I would go further. Apple's policy actually, they do all this marketing around recycling, right? And say, oh, we're so super eco-friendly. I can't remember their recent campaigns, but it's like we're using recycled aluminum or whatever. But the reality is that there are Apple certified recyclers, and I don't quite know what that certification gets you, but there are recyclers that have signed agreements with Apple to be, official Apple recyclers, and the agreement requires that they chip and shred devices. So if they receive a working laptop or a working iPhone, they are required to feed that through a shredder. Now, not all of them actually do, and not every recycler is Apple certified. But these devices, like, you want to talk about the environment, right? A laptop getting shredded down, and then having to try and extract any useful minerals out of that and then put those into the manufacturing pipeline to make a new device is way less eco-friendly than just refurbishing a device or just selling it used to someone who needs a device. I mean, I've seen photos of stacks of laptops that are going to get shredded or going to get parted out that are working, except that they are iCloud locked, right? The previous owner never removed their iCloud account from them, right? Which is, like, there are two sides to that story, right? I think a lot of the iCloud locked stuff really inhibits theft, right? And it discourages theft, right? You can't steal someone's iPhone that has an iCloud account on it and wipe it and immediately resell it. It's not to say that phones aren't getting stolen still. It does seem that there is an active trade in stolen iPhones to China for parts. But I think a lot of the attempts that Apple has made around iCloud locking and that sort of thing, and maybe even things like screen pairing, have been to decrease the desire for, or decrease the benefit of stealing a phone. The flip side to that is when consumers are done with their device, they're not removing those iCloud locks. And so, there's been a call to Apple to provide some path to like ask the original owner, contact the original owner and saying, hey, you don't have this device anymore. We got it at a recycler. Do you either want it back because it was stolen, or are you willing to iCloud unlock it? Either way, we want to get it back in the hands of someone who can use it. So, yeah. Green Giant says, with that, Lewis does a fine job at fixing stuff without the help of the manufacturer. So is it really necessary for the manufacturer to provide that stuff? Lewis is very talented. He is. But I think the thing that people don't realize is the legal liability aspect. For Apple, it's about protecting its brand. If you see a bunch of people getting burned because they remove a battery incorrectly. Yeah, I think the danger, this has been an argument that the right to repair lobby has used for a long time, which is that if you let people repair their own devices, that they're going to get hurt. And that's just not realistic. This is super simple stuff. I've taught kids to swap batteries on phones and swap screens and things like that. This stuff isn't dangerous. I mean, yeah, lipos in theory, but like that's not happening, right? We're not seeing tons of injuries from lipo fires from people trying to swap their phones. We're seeing it when phones get crushed in the seats of airplanes, and even then it's still rare, right? If you smash a phone, sure. I've done some pretty dumb things with iPhones. I've never actually gotten a lipo to catch fire, including when I tried to get it to catch fire. It wouldn't catch fire. So I really think that's a straw man that doesn't exist here. Is there a brand aspect to this? Yes. And I wish I could show your whole comment, but I'll read this part again. The thing I think a lot of people don't realize is the legal liability aspect for Apple. Two, it's about protecting the brand. So I do think there is an aspect of protecting the brand, and I think it's this. I don't think it's people getting hurt. What I think it is I think the issue is, let's say I sell you a used iPhone, or I sell, even worse, let's say I sell you an iPhone in the box with all its accessories, looks totally legit, but it's an iPhone that's had the screens, it's like a refurb, right? So it's had the screen swapped out, it's had the battery swapped out, maybe it's had the shell swapped out, all for low quality aftermarket parts, which totally exist in the markets, right? You can get some pretty crappy looking screens, and I have. And you can get some pretty crappy batteries. Shells, I've not seen one that looks terrible, but I'm sure they're out there. If you are representing, if that has all Apple logos on it, and there's no easy way for the person buying this to verify whether it's real in the sense of like Apple manufactured it or not, I think that hurts their brand, right? This is where like, and this goes into a whole discussion of fakes and copies, right? Which is, I don't believe that obviously low quality fakes are actually hurt a brand. I think they actually help a brand, right? So like the really low quality, like let's talk about like sneakers, right? A low quality like Yeezy copy in China that you're buying for $5 or $10, like everybody knows they're not original Yeezys. There's no danger of brand dilution. Instead, what you're doing is you're giving access to the brand to people who are a fan who don't have access to the money necessary to buy a real pair of Yeezys. And you're allowing them to participate in your brand and build sort of brand affinity, so that if and when they do get to the point where they can afford a real pair, they will. And the market shows that they do buy real stuff once they can get it, right? Nobody wants a crappy copy, right? You only buy a crappy copy if you really don't care or you can't afford the real thing. So, yeah, that's my thoughts there. Let's see. Yeah, Director Flick saying, I've handled thousands of LiPo batteries and I'm surprised how they held up. Yeah, do they catch fire? Yes. Does it happen often? No. No, it really doesn't. And yeah, they can blow up into a danger balloon, and it's still relatively safe, surprisingly. Yeah. This is a great point. Master Geo says, if I sell a secondhand car with all OEM replacement parts, that's seen as okay and normal. Shouldn't we see phones and devices the same way? And I think the answer is yes, absolutely. I don't know. I mean, I think you get into an issue when you have replaced all of the parts on the car with OEM replacement parts. I don't think that's actually realistic, right? But I think if you've replaced, a bunch of the parts, sure. Like I don't see anything wrong with that, right? Like the only risk is sort of brand dilution, right? If you're sort of representing that it is a factory original car, but you've swapped a bunch of parts on it, that's crappy. But I think we actually have laws against that, don't we? Right? I think you're required to disclose this. Oh yeah, it would be interesting to hear your experience, Obsidian. I know what experience you're referring to, and yeah, I'd love to hear the perspective of whatever you're willing to share, your perspective, or if you're willing to share some of your former employer's perspective, that would be super interesting. Yeah, let's see, catch up on chat here. Graphics here is saying like cars with a bunch of repairs like this often have a salvage title associated with it. And yeah, I don't know a ton about cars. I do know someone who bought a Tesla on a salvage title at auction. It had like been submerged in water and it had in a crash and stuff. And so yeah, like it was on a salvage title, but he got it street legal again and like re-registered. I had to go through a re-registration process with the DMV. What's interesting is, and this gets back into the right to repair discussion, because it was marked as totaled, which yielded a salvage title, Tesla, like, I guess, monitors the database of cars that have been marked as salvaged or marked as totaled, and removes them from the list of cars that are allowed to get software updates. So he has this Tesla now that, in theory, cannot actually legally get or cannot go through the normal mechanisms to get software updates. And so he's had to like root the car, and he has a friend who's rooted his car, and they copy updates over and stuff. But I think that's an example of a case where I don't think the manufacturer should be allowed to restrict that. It's still a Tesla. It still should be allowed to get updates. And the problem is we're just kind of outpacing the laws. We need some better laws around this stuff. Oh, this is interesting. So I don't know if you have another message here to lead into this, Obsidian, but Obsidian knows some things about shoes. I won't say any more than that unless he wants to, but he says some counterfeit products, especially in footwear, can use subpar glues that can be dangerous, either due to bad failure modes in use or the method of decomposition in adverse conditions. What gets into weird territories for brands is when consumers try and claim from the brand that had their products counterfeited from in the first place, and that's when things get nasty on different levels for both consumer and the brand. Yeah, and so I think the big issue here is just is really just a matter of what is the consumer aware of, right? If the consumer is aware of something being a copy or a fake, or they're aware that non-manufacturer parts have been used to refurbish a phone, and that the phone is refurbished in the first place, right? They know the difference between new and used, and used and refurbished, then I think a lot of these problems go away. It's when people are deceptive and are passing things off as new that it's a problem. And this is why, like, I've seen a bunch of people rant against the battery warnings, saying like you've replaced the original iPhone battery with a non-original battery. I actually think that's fine. I think that should be a warning in there. I think the same thing should be for displays. What I don't think is that then should trigger any disabling of software features, right? In the same way that your car might notice that you've swapped the battery, right? They can, the computer can tell that it's lost power, but it doesn't change the functionality of the car, or it shouldn't. So, yeah. But obviously, it does really impact a brand if the copies are actually like actively harmful to people. That's brand damaging. Probably even if people do know, right? It just sort of has this like halo effect. So there are some real issues here. Oh, let's talk about counterfeit ICs. Yes, this is a fascinating subject, particularly right now. I actually did a video at Creative Electron, which is an X-ray, a company that makes X-ray machines, and we talked a bunch about how to catch counterfeit chips. They actually have a machine that can take a reel of chips on it, in the plastic reel. I don't know if I have a reel for anything sitting here, or tape. I don't have anything immediately sitting in front of me. But I do have something that would make for a good show and tell that is reeled. Hang on. So this is what reel and tape looks like for anybody that doesn't know. These are particularly large parts that are in reel and tape, but these are capacitors. And the cool thing about these is that they're pink. These were a project by my friend Ian from Dangerous Prototypes. He was trying to make different colored capacitors, which is an awesome project. But he ran into some problems, so he never like fully finished it. But I get to go to the factory as they were running some tests. So anyway, I'm just trying to turn one in the right direction. So the idea is that this is in tape, in plastic tape for feeding into a pick and place machine, right? And so this tape will be very long. This is just a small cut portion, but I'm trying to get everything right side up because OCD, I don't know. And so this would be a very long strip that would be on a reel. And you get ICs this way too. You get chips this way. And so Creative Electron had an X-ray machine it was kind of like a reel-to-reel tape machine. So you would feed the reel in, load it onto the other reel, and it would advance one IC at the time and taking X-rays of each one. And the reason was that exactly what Director Flick is saying is that scammers will go in and find a similar looking IC in a similar size package, right, with the same number of pins and everything, and then will etch off the top of it and remark it with a different marking. So they'll take a particularly cheap chip and they will remark it as a very expensive chip. And so the X-ray is one way of catching this because they're looking at the lead frame. So the pin, let's take a very simple dip package, right? Dual inline package. Let me grab a dip. I'll show you. Let's have something here. So I'm just gonna grab an Arduino starter kit I have laying around that I think has some ICs in it. Doesn't it? Maybe not in this one. Maybe the bigger one does. One of these kits has some ICs we can look at. There we go. Okay, so in the simplest case, let's talk about dip packages. And in their case, they were talking about chips that are no longer being manufactured. And so they're in quite high demand for repairs. And so they were actually dip packages. But if you see here, like, right, we have this chip that has all of these legs on it, right? And the legs are part of what's called the lead frame, right? So it's this, I believe they're steel. And the black part is actually epoxy. And so the lead frame is bonded to the actual silicon die, and then the black epoxy package is poured around it. And so what they're using this X-ray for is to actually look at the lead frames, because while let's see, let's say I have two chips here, right? I have two chips. They look the same. They have the same number of pins on them. Do these actually have the same number of pins? Yes. But they might have totally different design to lead frames and the size of the silicon die and the wire bonding and things like that. So it's not a foolproof method. Can't tell you for certain it's possible for two different ICs to have the same lead frames and the same wire bonding, but it's much less likely. So, we've actually got a photo to show you. Thank you, mods. So this is a perfect example. So this is an X-ray of a lead frame, and you can see all of the legs here. Let me switch so I can actually mouse over. So these are the legs coming out of the package that I showed you. And then this is inside the epoxy package here. This is the rest of the lead frame, right? This is the rest of the leg. And it goes all the way to here. And then these faint lines are wire bonded. So it's really, really thin wires that are usually ultrasonically bonded both to the tip of the lead frame and then to the landing pad on the silicon die, right? And so that's how they bring it out to then be soldered to the board. Well, you can see there's some very specific design here, right? There's notches, like these two pins here and these two pins here aren't even connected. There's some weirdness in the shape of this die, right? These then become sort of unique factors that are harder for a scammer to find a chip that matches up. And they may not even, some of them may not even be sophisticated enough to note X-ray, though China moves incredibly fast. It is incredibly aware. So it wouldn't surprise me if they do. But you can see there's more uniqueness than just the outside of the package. So it at least raises the stakes for them. Let's see what else we got. I think this is just going to end up being a chatting stream here, unless we got folks who want to show stuff off, in which case holler. I was wrong about them being steel. They're copper, nickel, or an iron nickel chromium alloy. Solder wouldn't stick to steel. Yeah, that makes sense. I knew that was probably wrong as I was saying it. And yeah, Director Flick says when you decap an IC, which basically means you're somehow removing the epoxy package so that you can see inside and get to the silicon die, then you can see the actual die and compare it to the original. And yeah, you can, if you decap it, then you can use either an optical microscope or a scanning electron microscope to actually look at the die itself. And that's kind of the most foolproof way to compare it. The reason that Creative Electron was using X-ray is that the scammers have gotten smart. So they weren't replacing every chip on the reel with a fake one. They were only replacing a few. If you have really expensive ICs, right, really, essentially unobtainium ICs, if you just swap out a few randomly in the reel, you stand the chance of not getting caught, and you can still get a quite high profit margin, right? Imagine every chip is $100. You can fill it with mostly legit chips and a few fake ones, and you've increased your profit margin considerably, particularly if you're just a middleman broker. And the reason that you wouldn't decap everything is that decapping is a destructive process. So you're kind of taking a sample, destroying a chip to make sure it's good. It doesn't guarantee any of the other chips on the reel are good. It just guarantees the one that you've done is real. So I think if I were to do it, I would both decap a chip from the reel and I would be X-raying every single one on the reel to verify. Yeah. Let's see what else we got here. Can you decap and recap a chip? Yes, I believe that's possible. But I don't think you would want to do it and then trust that chip is going to be fully functional in production forevermore, would be my guess. I do know you can decap a chip and run it decapped. You have some issues with like light exposure. Light will change the way the chip functions. But yeah, I think that is possible. In theory, you could decap a chip, remove the silicon die, and repackage it. That would be theoretically possible, but it would be a lot of work. Yeah. Director Flick says if you have if they have more scrap parts reels at work, they'll have to send me some goodies. Sure, yeah, that sounds good. The PO box is down in the Twitch description, I believe. Correct me if I'm wrong, but yeah, yeah. If anyone wants to send me stuff, I guess that's another way to participate in show and tell here. If you want to send me something to physically look at on the stream, you're more than welcome to. I check the PO box on a regular basis, so yeah, happy to have it. Any plans to make my own smartwatch? No, not as of yet. I do wear a smartwatch. I wear an Apple Watch, which I originally started wearing because of my concussion. One of the effects of concussions is that you often people will get more symptomatic. They'll get headaches and things like that as their heart rate increases due to some dysregulation of the central nervous system. And so one recovery protocol, rehabilitation protocol is the Buffalo treadmill test protocol. So you basically, ideally it's done on a treadmill. I didn't have access to a treadmill at the time, but the idea is that you walk on a treadmill and gradually increase the effort over successive minutes until you start to feel a headache or other symptoms. And you then look at the heart rate and then you exercise at 80% of that. I think 80% is right, but a lower percentage, and use that to like gradually reacclimatize the body. And so I was using the Apple Watch as a heart rate monitor, and, as well as just a continuous heart rate monitor throughout the day. It was okay. That protocol never really fully worked for me. Doing interval training was a far better match for me in terms of recovery. But in terms of building my own smartwatch, yeah, I mean, I've thought about like redoing the whole how I made my own iPhone with other devices. And I briefly looked at watches, I don't know, like 2 or 3 years ago, pre-pandemic. One of the last times I was there. And like there are some parts. There are so many fewer parts of anything other than iPhones in the markets. There's just so many iPhone parts that project is way easier. You know, I've thought about doing a MacBook. I've thought about doing an Apple Watch. I did the Android, which actually turned out to be more challenging to find parts than I expected. You know, so I don't know if that's if doing it in that way of like buying all of the parts a la carte for, say, an Apple Watch and piecing it together. I don't know that that's that interesting if I do it via the mail. It's always been my feeling that it, you know, really part of what makes that story interesting is doing it in the markets. So, you know, is it high on the list? No. I'm currently working on some iPhone stuff, which I think is going to open some big doors here in terms of customization and the ability to make cool stuff. So that's kind of been my focus right now. Would I consider doing a watch in the future? Sure. It's just not a huge priority right now. Wolf Toasty says the PO box sounds like a perfect place to dump the 2000 RGB LEDs I bought by accident. I mean, I won't say no. I'll find something cool to do with them. You're more than welcome to. I'll take them. I'm always, you know, always looking for cool parts to have around the shop to put in projects. So yeah, we could do something cool with those. That 2000 is a lot to buy by accident. Well, Ultra Whip, we'd love to have you show off your projects another time if you're not able to show them off today. I think this is going to end up being a pretty chill stream here, but yeah, like I said, anybody's welcome to participate. Oh, we do have some folks. We do have some folks now. Let's get some folks in here. It looks like Sahko is on the list. Let's get Sahko teed up if we're not already doing that, and then. Let's I'm gonna go ahead and talk about RedTheTech. RedTheTech has sent something in. So let's talk about that. And then I'll go back to some questions here. I'm going to start this and come back to it. Hey, RedTheTech. Thanks for submitting something. Okay. This is dangerously close to just blatant advertisement, but we're going to do it anyway. Because I think you're coming from a good place. So RedTheTech asked for me to review his web store, and it looks like it's, well, let me check what it is before I pull it up on stream here to make sure it's appropriate. I don't know if anybody's vetted it. Nosh sent 100 tiny rubber duckies to a streamer's mailbox. I love it. I, at one point, priced out how much it would be to buy an entire shipping container of rubber ducks, and it's less than you'd think. Oh, awesome. Okay, yes, we will totally talk about this. Okay, let me share this tab instead. So this is RedTheTech's store, Magic from Plastic, and it looks like you're selling 3D printed parts. I don't know why nothing is showing up here. It could be that, oh wait, hang on, sorry. I gotta show the, here, hang on. Here we go, okay. I don't know why nothing is showing up on top. It could be that I'm using the Brave browser. So that would be obviously be the first piece of feedback, would be to check it in Brave with the shields up. I'm gonna try lowering the shields on Brave. Hopefully this is not a giant phishing attempt. Okay, yeah, there's something stopping this from loading on Brave. We specialize in 3D prints for your home, office, wedding, anniversary, birthday, or other special event. From a single print to a series of prints for your wedding or other special event. We can help ensure that whatever your idea, it can become magic from plastic. Custom models available on request. Awesome. I might play with this. This is a lot of text to have at the top here. Also, is this isn't Comic Sans, is it? This is an interesting font choice. It doesn't look, yeah, this font, the design of this makes me feel like maybe this isn't super professional, just like from a gut feeling perspective. Okay, so shop by categories. Pencil holder. The font is National Park. I'm not familiar with that one. Don't think this image is showing off very well. Like it has a lot of stringies. So I would immediately see that and go, I don't know how I feel about that. So you might want to showcase a different image there. I think also you probably want a non-see-through background for this photo. And then, yeah, I think I would show it not on the printer bed for this one. Prices seem reasonable. I think the question I have is like, why would I buy a 3D printed pencil holder over like an injection molded one? Custom, let's see, seasonal items. Doesn't look like we have any photos here. So you definitely want some photos there. Oh, these are cool. Cookie cutters is a great idea. What options do I have? I'd say this is formatting a little weird. And I think you want to like better advertise the colors you have. Like I would want a description of what colors you have, because I think these are probably color changing filament or like gradient filament. And if I didn't know a lot about 3D printing, I wouldn't necessarily know that. Yeah, but this is cool. Good idea. I think I would, if you're going to sell cookie cutters, you should have a lot more designs. Wall decoration. Yeah, I feel like this needs to be like a little bit fancier. Like this looks like an unpainted 3D print, and you might want to consider like how can you sort of spiff this up a bit and make it look a little bit nicer? Like, what about if you painted it with like rub and buff, like and made it look like it was like antique copper? I'm pretty sure you can just go to the hardware store and they have all sorts of interesting paints that you can use to spice things up. Again, these look good, but like they look like raw prints. So I would say, like, for something decorative, how can you spice it up? Let's just look at one other. Let's go to Halloween here. Oop. Thought I clicked on Halloween. Oh, maybe I didn't. Yeah, these definitely need pictures to figure out what they match up with. These are cute. I think one of the questions is like, well, one of the questions I have is, are these your designs or not? And are you going to run afoul of somebody else's license? I don't know what. Like, are you watching your license? I would want to be able to click. Oh, I can't click on this. Whoop, that's a 404. So obviously want to fix that. That was on custom prints. Definitely fix that. I think just doing a sweep overall through the site. Yeah. I see what you're going for. Wedding toppers is interesting, right? Like custom wedding toppers. That's cool. Yeah, I mean, I think it's decent. I would go through and just kind of do a full pass on it from just a QC perspective here. About. I think the real question is, how are you going to reach your target customer, right? Yeah, this is good. A video, I'm assuming. Nice. Yeah, I think this is good. I think it's mostly a question of yeah, how are you going to reach your target customer? And you said Facebook and search mostly. The place that I've seen people, I don't know how much they're selling, but it looks like they're successful, and I considered buying from them, even though I own a 3D printer, is people selling really niche parts on like eBay or Etsy. But it's things like a bracket to convert my router to run on the track for my track saw, right? And they're charging like $20, and the model is not freely available, and that's pretty compelling. I have a hard time because I have a 3D printer, and I'm like, I don't want to pay you $20 and like shipping and waiting for it and I'd rather just like pay for the model and print it myself. Yeah, I think if you can figure out how to niche down. I think the other thing is, like, I would consider figuring out how to rebrand as like a, we make custom cookie cutters, right? I think that's a better business than we do 3D printing and we have cookie cutters, right? So it might involve actually creating multiple storefronts, right? You can consider like creating an Etsy store that is custom cookie cutters and have a whole bunch of different cookie cutter designs, and then also make it really easy for somebody to send you a photo or a drawing or something and turn that into a cookie cutter, things like that. So, yeah, I think the danger with things like 3D printers is as makers, we think of it as a tool, and you're like, well, I can do anything on this tool. And we sort of advertise it as like, come use my tool, or come, pay me to use my tool for you. And sorry, I'm getting messages from Sahko here that are backwards that I can't read. I'm something box. I think Sahko's ready. I'll get to you in a sec here. Go ahead and type it in the private chat and I'll be able to read it. Yeah, I think you want to get away from being tool centric and head towards solution centric, right? So someone who's going to buy a cookie cutter isn't saying, I need to go find someone with a 3D printer. They're saying, I want to buy a cool cookie cutter, right? So a little bit of marketing advice. Yeah. I think let's go ahead. Oh, what 3D printer is this? This is a Creality CR10S Pro V2, I believe. It's fine. Does what I need. It's not too fiddly. Good enough. Okay. Sahko's distracting me here. Let's go ahead and bring Sahko on. Thanks for showing us your site, RedTheTech, and good luck with it. I think there's definitely a business to be made there. Sahko, I'm assuming you're ready if you're sending me secret messages via text pad. Okay, yes, I'm getting the nod here. Let's bring you in. All right, welcome back.
Yay!
Good to see you.
Pleasing circle. Oh, I can hear myself.
Yep, hang on. I'm on the wrong. Partly my end.
Yeah, the message was just said, "I'm trapped in this box." And I thought it'd be funny if I just hold up a sign as opposed to actually typing anything.
The problem is it's backwards for me, so I can't.
Yeah, I saw that on the thing. I was hoping it'd flip it back, but everything's backwards now.
So we don't have an echo. Hang on.
I can't hear myself anymore.
There we go. Now it's working.
Hey.
Yeah. How's it going? Welcome back.
Your audio is kind of strange. It's kind of muffled in a way.
Muffled. I might be on the wrong mic. Let's see. No.
No, it sounds better now. See, I think it was just a one-time thing.
Okay. Okay, cool. Awesome. Well, welcome. Well, what do you have to show us today?
I got the PCBs made.
Oh, nice. For
my Precision Voltmeter that I showed off in the first show and tell.
Awesome.
So I paid, it was about £6 or $6 or whatever for 5 boards, but I ended up paying €80 to have that stuff shipped in like days. So I ordered it on a Friday, received it on a Monday. So
who'd you have do it?
JLC PCB. So the place you toured, or showed off, I guess.
Yeah, and I really like JLC. But it's getting it to you in a timely fashion that's expensive.
Yeah. I'm surprised I actually got it as fast as I did. Because supposedly it was going to be 48-hour turnaround and 5 or 6 days shipping. It ended up being 4 days to the door.
That's pretty awesome.
Like it was really quick. Awesome. I couldn't get Amazon packages that quick half the time.
Yeah. Perhaps fatal mistake was that the very first PCB I made was on my first trip to China. And so I have gotten totally spoiled by turn times in China. It is like 48-hour turn.
See in half an hour, basically.
Yeah, well, 48-hour turn is standard. If you're just doing like 2-layer green, default settings, default trace widths and everything, 48-hour turn, and then they courier it across town. So you get it in 3 days. And if you pay, I think, $30 extra, you get it down to 24-hour turn, and you get it basically the next day, in a day or two.
The way they do that is that's actually like a priority queue, but because they're so fast normally, you're going to get 24-hour turnaround time anyway.
Yeah, right. It depends. It's actually interesting, at least for the Chinese-facing business, it very much depends on the time of year. So like right now, everybody's coming back from Chinese New Year, and their turn times will actually fluctuate a bunch. I've seen turn times, like standard turn times, out as far as like 4 days. So yeah, well, show us this board. I don't know if you've
there you go.
You got it. Yeah.
It's not as obvious. Like, there we go. You can see the cutout.
Yep. Now. Nice.
But you can see the weird floating capacitor above it.
Yes.
I screwed
What's that about? Ah, okay. That's a bodge.
So it's a bodge. On the bottom, there's one chip.
Hang on. Let me make you full screen here.
Yeah, there you go. Okay. I don't know how high the quality is, but
that's pretty good.
You can see the one IC on the bottom. There's a couple of bypass caps, which is basically just like across the power rails.
Yep.
The one for this chip is underneath this one. Accidentally, so you can still see the bit of silver poking through, right?
Yep. Yeah, that's underneath that IC.
Well, the pack or the footprint is.
I can't. Oh, whoops! So I'm surprised your design software didn't flag that.
Oh, it did. I just didn't care. Like because whenever I do the DRC check, as long as it doesn't like completely screw up, I just ship it and post it. Like,
oh, I'm like super anal about the DRC checks. So for anybody that hasn't designed circuit boards, the DRC check is the design rules check, and it basically there are a bunch of rules that you get from the circuit board manufacturer, JLC in this case, as to what their tolerances are on their manufacturing process. So how, what's the minimum width for your traces? How far do they have to be apart? And this is just to guarantee that they're gonna be able to manufacture it in a reasonably on their machines without creating bridges between traces and things like that, or short or open circuits or anything like that. So I usually am like super anal about that and make sure that they get a file that they definitely can produce.
Because the chip on the bottom was an afterthought. So I'd done all that anal preparation, and then it's like slap that chip on the back because I was going to do it kind of on this far end that's kind of blank at the moment.
Yep.
But I thought, no, I'm probably better off putting it closer because of what it does.
What are all those pads that you have on top? Is that just decoration?
It's actually for a little prototyping area because this is like the.
Sorry, I meant on the bottom corner. That
same
sort
thing.
of grid. Oh, okay. There are those.
So instead of they're squares, but instead of like a through hole prototyping area, they're actually just pads for normal like surface mount prototyping. Okay. So along with that, I also got a couple of these. They actually emailed me about these, saying that like these might actually be like.
Whew. Can you hold those closer? Those are super fine pitch.
It's 1.27 millimeters, so it's half the pitch of a normal dip package, or dual 9 package, or whichever. They were complaining about about manufacturing these, because there's a possibility that when I received them, they would just be all one big solder kind of blob.
Oh, because you did hassle for your surface.
Yes, because I didn't want. I'm not going to be paying. I'm not going to be gold plating a prototype board. So,
but do you know? I mean, presumably you've seen the JLC video where I showed the hassle process. Like, do you know why they were worried about it?
Yeah, no, I understood it, but I'm like, I don't want to pay for like I got 5 of these. I'm not paying €45 for 5. Prototype, because the whole point of JLC is that you get them cheap.
Yeah, that's
shipping aside.
So for everybody who doesn't know, hassle is hot air solder leveling. So, the circuit board itself has copper traces on it, right? And I guess maybe you'll know better than I do. I guess, the surface finish makes it easier to solder. It's kind of like tinning the board ahead of time, at least with hassle. Is that accurate?
That's mostly what it's used for, yeah, because it's just solder to solder. Like, that's why you actually wet the tip of your soldering iron. Right. Because otherwise you're not going to be able to melt anything. Like, because
you've got sort of an oxide layer otherwise.
Yeah. That would be enough to just stop any heat transfer completely.
Yeah.
Or at least to the point where you can't really solder.
Yeah.
Because it was annoying at work because we have like $8,000 worth of soldering irons and reflow stations, and I think it was 9 out of the 10 tips were completely useless. You couldn't use brass wool or anything to grind. Like, that's why I have this like little tub of brass wool, is to be able to get rid of any oxides and stuff.
Yeah, exactly. That's what I use. I've stopped using a sponge. I just use the brass wool now. And that's been pretty effective. But the hot air surface leveling is basically a process where they take the board and they dip it in a vat of molten solder, and then as they pull the board out, they've got air knives. So basically, like a long thin jet of air on either side of the board blowing down to blow all the solder off the pads. It's the cheapest sort of surface finish. But obviously with something that's that fine pitch that has that much surface area of pads, the danger is that you get bridges between your pads, and that the solder doesn't blow all the way off the way you're hoping. So
yeah,
I can see why they were.
I did check
worried.
All of them, and they were all perfect.
That's awesome.
Except for the design I sent them. These look. Do you see the weird kind of? It looks like aliasing in the camera, but do you see how some of them
Yeah.
seem to have like lines?
Yep.
That's not supposed to be there. It's supposed
What
to be
was
just
that from?
because of the way I made them. I made
You cut
one
and paste?
square. I copy pasted it, and then I copy pasted these chunks up. Then copy pasted that chunk up just to make it easier to, and it's double sided as well because mine as well. So
Yep.
at certain points they are about, I think it was like 10/1000ths of a millimeter closer. But it's one of those things that I only realized it once it arrived.
Yep. Yeah.
The same thing with
Yep.
this. It's like it looks all well and good on the in KiCad, but once it arrives, that's when you realize you've screwed up.
I think this is the advantage of particularly the 3D visualization, right? And I think eventually we're going to get to a point where
I didn't notice.
we have better visualization, but yeah, it's being able to see like parts overlapping, for instance, should be something that we should be able to easily solve in visualization.
Not if one part completely covers another.
Oh, that's fair.
And that's why I didn't spot it, because I had that
enabled. It still should put a big red arrow, and be like, this is a problem. Which
Not
I guess
if you
it
clear
did
the
in
design
DRC,
rule check.
Yeah. Yeah. Wolf Toasty says, if only DRC would have warned you about that.
Well, that thing, it wouldn't have. This it did. It probably did. I just disregarded it completely and then paid money for it.
Yep.
But yeah,
nice.
My main issue now is trying to get my CPLD or the logic for this working.
Yep.
Because Intel software is completely useless.
And that's a single board computer.
It's CPLD. It's a complex programmable logic device. It's like an FPGA, but smaller.
Okay.
And so the whole point is basically like all I needed to do is to have a couple state machines and an SPI bus to communicate with a microcontroller. That's all I need.
Yep.
I've been working on this for 3 weeks straight now, and I've not even gotten any of it working.
Yeah.
I today I'm reinstalling all of the software because it has these things called like IPs, like intellectual property.
Yep.
That is kind of public.
IP blocks,
So if you don't want to reinvent the wheel for the 7,000th time, you can just import what Intel's already done for you.
Yeah.
In terms of the type of code. That's not working. A mate of mine on a different Discord installed the software and in about 15 minutes had it working, doing exactly what I did. And
this
at this
is
point,
what
I've
I find
actually run out of
super
options.
frustrating about like embedded, particularly with like, and it's been a while, but it's what scares me about getting back into FPGAs is that you have all these really proprietary vendor tool chains, and they're not the most user friendly, particularly when it comes to things like installing them. Unless you have a very expensive support contract or something like that.
Yeah, unless you can literally have a person drive down and be on site to teach you how to use it.
And companies do that, right? If you're a big company, that's producing a laptop or something, it makes sense for everybody involved to do that, to fly somebody out and station them on site to be your
I knew someone who did that.
Hand as you're doing it.
I know someone who did that for BMW. They were sent off and they were on site as they were a junior engineer at the time. But no one had told any of the BMW people. So he's always sudden put on this pedestal of being given like stuff to do, and he's just like lost completely. And it took him weeks to find out that everyone thought he was like the top end engineer or whatever from the company he was working at the time, even though he was basically like a 25-year-old who had no clue what he was doing.
That's awesome. That's awesome.
But yeah,
Wolf Toasty says drivers, I don't get this. Driver's licenses are by far the most limiting factor of the upper end of PCB and firmware design. I think they're saying basically getting on site is the limiting factor. Yep. I think that's probably true. Yeah.
I thought he meant more like firmware drivers.
Oh,
like the licensing for that.
Yeah.
I mean, they're both kind of true.
Not driving licenses, but the licenses for drivers. Yes.
Oh, so yeah, right.
Yes. Yeah, you're right.
Yeah. I just remember, like, there's like a little, like a, you know how like on the Arduino, like you've got like your blink LED kind of thing just to test everything's working. This CPLD actually has the same sort of thing going on it. And I got that working, and I was like, cool, let's try some combinational logic. Let's get a quick adder working. Cool, that works. So I thought, oh, well, give me 2 weeks, I'll have it done.
Yeah. So you have the basic like debug loop working. You can load a design on there. You just can't load the IP blocks.
I can partially.
That's frustrating.
I can partially load it. Because like for anyone who doesn't know, the way CPLDs are programmed, you wouldn't program them in C or Java or anything like that. They're done in what's called a hardware description language.
Yeah.
Where you're using software to describe hardware. And the main two are Verilog and VHDL.
Yeah.
And because our college is full of wonderful people, we decided to learn the most difficult of them, for whatever reason, VHDL. Which I got through the teething pains long after I did my exam, which for some reason was doing VHDL on paper.
Yeah. Oh my God. Yep.
And it's not just like you have to fill in the gaps. You had to have the library declarations, all the declarations, all the syntax correct. Yeah. Otherwise, you got no marks for it.
Oh, jeez. Yeah, I'm all for writing code on paper in certain circumstances, but that's a little extreme. Usually, yeah. I have people write on the whiteboard in programming interviews back when I was hiring programmers, and I think that is valuable. But I don't care about can they declare the right library, right? It's, I do care if they could write in the right syntax in the actual language, right?
The main problem is the software we were using AMD's VHDL suite, Vivado, which does a lot of that stuff for you. You just create a file and it's got the declarations there, and any ones you want to do on top of that, you just do them.
Yeah, right.
But and so you did them in this one, I'm just going to copy paste them. Yeah. So all of a sudden, you have no idea how to actually do it. Yeah. But we were saved by the fact that he had a bit of example code.
And so you could sort of crib off that.
So you can kind of just about get by on the declarations part.
Yeah.
But you still have to do the rest of the code by hand.
Yeah.
So I'm having to redo that.
There's value in that. There's some value in that. But yeah, I've done Verilog. I did Verilog in school. And I'd love to get back to it. It's more the fear of bringing up the tool chain as you're talking about, of getting all
the funny thing is
software installed on your PC and all that stuff.
It's kind of interesting because Intel is still kind of transitioning, because Intel wasn't the company that had all this originally. It was Altera.
Yeah.
And Altera was bought out by Intel, but all the tools are still the same. But unfortunately, so is the documentation. So for Intel's FPGAs, they're looking at the likes of NVIDIA for the large ultra scale, whatever, the very expensive FPGAs that cost nigh on 15-20 grand a board. Yeah, it's like,
that's brutal.
The amount of money people pay for melted sand is amazing.
Yes, it is.
But when you pay about, I don't know, like €120 delivered for this, Intel doesn't care. So like the most up-to-date documentation is from 2014.
Yeah.
And so the software has gotten so far ahead that none of it is compatible. Yeah.
I've looked at a little bit. Well, I've had conversations around MediaTek chips, particularly in cell phones. And it's similar in that it is very locked down by the vendor. It's very hard to get access to the MediaTek development environment and necessary documentation to develop for MediaTek devices unless you're a really big customer. And so, you end up having to work with, even in China, you sort of end up having to work through contract manufacturers who do have those relationships. But then, I kind of looked at it as the discussions I've had in the past have been around how do you build a MediaTek device that's open source? And the reality is it's never going to be fully open source, right? You're going to have a bunch of huge binary blobs that MediaTek gives you, and you're not going to be able to give people full documentation or development environments. So this is something that I don't fully get it. Like, why, you look at like Atmel, right? Atmel has seen huge adoption of their 18 mega line, right? Because it's been in Arduinos and there's full access to a great tool chain for it, and there's full documentation, right? And it's become this weird de facto industry standard, despite not really necessarily being the best chip for the job, right? And I don't get why people like Intel and MediaTek and things like that keep things so locked down behind closed doors. Once you get to a certain level of sophistication in silicon, really hard to even get sample chips, let alone the documentation you need to use them. So
yeah, the interesting about
really
this
wish
is
that would
it's
change.
not even like it's locked down. It's just what is available is what's available, and there's nothing really behind closed doors, because the whole point of these products is that you can do whatever you need it to do.
Yep.
The problem is that the software was built for Windows 98,
Right.
and then just built on from there.
Right.
Like, there's another for their simulations, because you can simulate all of this stuff before you program it onto the chip.
Sure.
They've got limited write cycles, and for that they use Model Sim from Siemens, but they use their own version, not the modern version. And their own version on my beast of a computer, it struggles to resize windows and drag it across. So if I drag it across from one window to another too quickly, it just resets itself back to where it was, because it just doesn't know what's going on.
Oh my God. That's brutal.
Yeah.
That's totally brutal.
And my hoarding tendencies actually came to light and were quite useful, because I think I've actually lost it now, which is not a good example. Oh, here it is. There, like, how old hard drives had IDE cables instead of SATA cables?
Sure.
I had one from a computer that was given to me probably 10 years ago. I salvaged.
Yeah.
The headers on these are exactly the right size. So this random cable that's been slowly wasting like space in my room finally managed to come into its own.
That's awesome.
So
that's awesome.
That's where you should hoard things, kids.
Yeah, but hoard things in an organized fashion so you can actually find them. I'm finding the shop has reached this critical mass point where even though things are reasonably organized, I am now scrambling to find things that I'm pretty sure I have, but I have no idea where they are.
I think at this rate, my setup might literally hit critical mass, like with like radioactivity and everything, just from the amount of crap.
Yep. Yeah. Well, you seem like you have a fair amount of test gear that are taking up space too.
The funny part is I'm trying to downsize. So a lot of the test gear that I've got, I've probably sold about €1,500 worth of test gear in the past 2 months, all of which I've replaced with more. This power supply I got is new.
Yeah.
Haymeg one, because I wanted it to be smaller.
Yeah.
But I literally today got an offer for this, and I got a new multimeter down here, sold a different one. So it's like I'm just replacing stuff at this point.
Yep, that's kind of the way it goes.
Yeah, I've got so much stuff to set up as well. Like, I managed to actually find a Raspberry Pi for a somewhat decent price.
Oh, do you want to name your secret? I know that people are struggling to find those right now.
Buy broken shit on eBay.
What was it?
It was the SD card on it. The SD card slot was sheared off, and it was hot glued back in place.
Oh, so if you fix your own, you can get broken ones.
Yeah, but
nice.
When I received it, that was that was the only issue.
Yeah.
When I held it for longer than 15 seconds, I caused another issue where I knocked a capacitor off. Which normally not that big an issue. I've got capacitors out the ass.
Sure.
The capacitor was, what size was it? Let me just, I think I have it somewhere here of the spares. There we go. somewhere under this pile of shit. It's 0402,
Yeah, those are pretty small.
which are like absolutely tiny. You can try and get an idea of how small that is there.
Yep.
Yeah.
I will say it's not
It's kind
impressing
of
me
focused,
because
right?
I've been recently dealing with 01, 005s on iPhones. So
But were you doing them by hand?
yes,
Why?
I don't know another option.
Jesus Christ.
How should I be
Were
doing
you
them?
using a hot air gun?
Yes.
I wasn't.
Ah, I see. Yes.
I was using, because I've got my like I made my own soldering station with a JBC
Okay.
handle,
Yep.
and so I was using this.
Yeah, 0402
tiny,
is
it's
small enough to do with,
it's doable.
Doable with a soldering iron. Yeah.
Hopefully without damage. I did get, but like the problem is like, cool. I've got this thing that I've been waiting to screw around with for months. Finally got it and screwed it up immediately because it wasn't like just a generic capacitor. It was part of the clock circuitry, which meant that it was completely dead.
Yep.
So what I ended up doing was the Pi Pico, the tiny Pi Pico, has the same capacitors on it.
Oh.
So after about 45 minutes of trying to get one off, I finally got it, what I thought was on the pads correctly, because the pads are very small for whatever reason. Like there's plenty of space for a bigger cap, but they just, I guess, decided to use those.
Well, part of it is the capacitor shortage that was really rearing its head a year or two pre-COVID, meant that people are moving to smaller and smaller capacitor packages. Like it became hard to get, the larger packages. I'm trying to remember what the sizes are, but like, what is it? 0804 and
0603. 1208.
The 1208 was definitely getting hard to get. 0804 was hard to get. And so they were moving down, even in designs that didn't need it, they were moving to 0402 and 0201 just because of part availability.
Yeah. And then I knocked it off again.
How are you knocking it off?
With my eager, because I didn't actually solder it on.
Oh, I see.
And once something gets on my floor, even though it's a hardwood floor, it's gone.
Yeah, I'm the same way. I've shot several of these 01, 005s across the room, and they're gone, right? I mean, they're like, I don't even have a good analog to compare how small they are, right? Like a poppy seed is larger than them.
I'm trying to think, that's what, like it's like 0.1, like in metric it'd be 0.1 of a millimeter, so it's I think 0.1 of a thousandth of an inch or something like that. So 1/10,000th of an inch.
Yeah,
maybe.
They're small enough that I confuse them with specks of dust, or specks of dirt on the bench, and so it really leads to this, like, sort of drug-addled frenzy. It looks like I'm a drug addict, like sorting through the dirt on my desk under the microscope,
looking for the last fleck of whatever.
Yeah, right, exactly. It's ridiculous, and they're so small. So I've been putting them in little flip top boxes. Where are they? Oh, they're over here. So I have these little flip top boxes here, which I like. And they have little things you can flip up the lid. They're great for little components, right? So
I've been 3D print those, because I remember seeing there's STL files for those.
No, I bought these from China. I bought a couple like flats of them. They come in sets.
I need to get something like that
full of
soon.
them, but
Scaverat brought up a good point in the backroom chat about how there's two different types of 0402. There's metric and imperial.
Yes, that is true.
So
that is,
like, for example, true. Imperial 0402 would be metric 0201, I think.
Yes. Something like that.
Extent.
I'm not even sure if it's directly comparable, but
another person said like that they might be the size of a grain of salt or sugar. It is far smaller than that. It is like a 10th or a 20th of the size of a grain of salt or sugar.
Maybe not quite that small, but like, that's...
It might be like a grain of flour for all it matters.
Yeah. They're so small that I have to use the microscope to see if it has come off the tip of the tweezer when I'm trying to put it in one of these flip-top boxes.
That's one thing I found. I don't know if you get the same thing, but just things just stick to your tweezers.
For sure. Yeah. So I regularly clean them with isopropyl, and that helps, right?
I normally pick my fingernails with. I should probably clean mine a bit more often then.
Well, it's the residue from like flux that gets on the tweezers, and then they become sticky. And so the isopropyl will get that residue off.
Just sprinkle them on the PCB with a salt shaker and put it in an oven. Scaver
Absolutely.
Scaver knows the pains of SMD soldering.
Yeah.
I can just tell
so
just from
my current challenge, I have been pulling these 01005s off a logic board in attempt to.
Well, I'm not going to ask why, because it's probably.
I'm not going to say exactly why.
For a special project, but
it is
I
for
can't
a
think
secret
of
project.
a cohesive reason why.
Yeah, well, it turns out that I may have been misled, but I was under the impression that I should pull these off. And so I've been saving them in their own little bins. But now comes the question of like, so I have two problems. One is I have lost several in the process of pulling them off because they
good luck finding out what they used to be.
Right, exactly. And that's a challenge. But even the ones that I have, they're so small, they're very hard to measure, right? So I have Daniel over at Keysight. I went down and saw him a couple weeks ago, and he sent me away with an LRC meter, which is great. So it's
like a handheld,
little handheld. Yeah,
I thought you were like the Keysight
or
like,
LCR
benchtop ones that are.
No,
you'd be surprised, surprised how expensive those actually get. Like,
yeah,
but they come with these sort of fixtures as well.
An LCR meter answers the question. I have a component that is right. What is it? Is it a capacitor? Is it a resistor? Is it an inductor? And what value is it? And it will kind of do that all in one shot. The problem is that these things are so dang small that I somehow have to get probes to them. And so I have like my needle probes, right, which are essentially sewing needles on the end of multimeter probes. But they're kind of on the big side. And this thing is so small that it's easy to just flick it into space with a needle probe as you're trying to get the other one right up to it. I'm doing this all under the microscope and then sort of peeking around the microscope to look at the LCR meter. The other option is like you can get tweezer probes, right? But the tweezer probes, the cheap probes that I bought on Amazon are way too big. Like they're not fine tips. So right now I'm debating ponying up. I'm trying to get Daniel to send me their fancy tweezer probes. Otherwise they're like $140. The tweezer probes that go with this LCR meter. So
yeah, the funny part is like he would send them to you happily, but it's a matter of whose arms he has to twist.
Yes, exactly. No, absolutely. Daniel's a great guy, and we're definitely going to do some more stuff together. But
he's got one of the weirdest Twitter accounts I've ever seen. Like, I don't know where he finds half the stuff he posts about or retweets.
Yeah, he's got all sorts of good stuff. Well, this has been good. Thanks for sharing your progress on your multimeter project here. I'm excited to see it in action.
I've got I think 5 or 6 weeks to finish it.
Oh, geez.
Which is why I'm really annoyed about this VHDL stuff.
Maybe we can dive into it more because we talked a bit about it last time. But I would like to hear what is I know there are a lot of moving pieces to this, but like when we get down to the actual measurement of voltage, can you walk us through sort of the basic design there? Because I know the premise for this is you're making an extremely precise voltmeter that goes to 8.5 decimal places. Is that right?
8.5 digits. So
8.5 digits.
Generally, it'd be about 6 and a bit decimal places.
Okay.
Because you still have to have the main.
Sure,
that's how it's generally talked about. But another way of thinking of it is 28 bits of kind of a string.
Okay.
But the main working principle of these, of very kind of high resolution ones, is converting the voltage into some form of time type measurement.
Oh, okay.
So the most basic way to do that is to compare how long it takes to charge a capacitor versus how long it takes to discharge the capacitor.
Okay.
So you have like a reference signal or a reference voltage of 5 or 10 or whatever. And that's what's used to discharge the capacitor. So you charge it for, say, a millisecond.
Yep.
With your unknown signal. And then you see how long it takes to discharge it. And if it takes half a millisecond to discharge it, you now have the ratio between your input and your reference.
I got it.
And so when you get beyond that, you start getting into kind of clever ways of increasing how long you can sample for without maxing out the capacitor, or like just kind of, what is that noise?
Sorry, there's someone working downstairs. I've got an assistant installing shelves downstairs.
It sounded
I
like
didn't
one of
realize
those like automatic soap dispensers.
Oh no! It's a drill running there. It's a
Right.
someone driving
Yeah.
screws.
So like to get kind of beyond just that basic measurement, which has been around since the 70s, 80s, or even early 60s probably.
And what's the trigger? So you're charging up a capacitor and then you're hooking it up. Are you reversing polarity and hooking it up to your 5-volt source, or
You can, but it's kind of more of a pain in the ass to do it that way. So like,
because presumably you want to be able to measure less than your voltages that are less than your reference voltage, right?
Yeah, but if you do it right, you can actually measure ones that are more than your reference voltage because of the way it's set up. Because you're
basically, you're either charging or discharging.
Yes, and you're basically waiting for it to cross zero, because it's a bipolar thing, so it can go negative, it can go positive. If you put a positive voltage into the integrator, it's called, because it's just like an op amp with a capacitor across it.
Yep.
A positive input will actually cause a negative output.
Okay. Yep.
And then you apply because you normally have two references. You have a positive one and a negative one to then steer it back up. Then once it gets back to zero, you're back where you started. You've got your ratio.
Okay.
Now it's far more complicated than that. And probably far too much to go into within the next millennia. But that can only get you so far. Because your resolution comes from how fine you can measure the time.
Right, sure.
And so if you're measuring it at 10 megahertz or 20 megahertz, that'll probably get you 2 or 3 digits at most, if that.
Right, okay. Yep. Because your digits are coming from what is your sampling rate of this?
Yeah.
Of this
capacitor. You're counting. Like that's why when you hear like multimeter counts, like this is a 20,000.
So you're counting clock ticks, waiting for this, for the output of the comparator to go to switch from low to high or high to low. Yeah.
Yeah.
Okay.
And so beyond, like, that's kind of the basic kind of algorithmic way of how it works.
Yep.
Which is fine if you're trying to just do basic measurements.
Sure.
But once you start getting into a finer and finer resolution, just the laws of physics start to apply. And like, because you're less integrating the voltage that goes into an op amp and more the charge. So you've got it going across a resistor.
Right. Yep.
It's like, I don't know if I can share just a quick schematic.
Yeah, I was going to say at some sampling rate, you're actually kind of have a your measurement is changing your voltage, right? Because you're actually using some of the charge in that capacitor to run your comparator, right?
Not if you're, because you normally have an amplifier on the output, so you don't do that.
Oh, I see.
Just to kind of make sure. So I don't know if I can send in a photo just to kind of give people an idea of what I'm talking
yes. About. Put it in private chat and we'll make it happen.
Can I just copy, or I'll put it into the Discord and maybe one of the mods can grab it.
Yeah. That works.
I'll put it in the back room.
Perfect.
Yeah, we'll get it's got transparency. Damn it. This one, no, there we go. I'm putting in a second better image because that one's a transparent background and it just appears all weird. But basically, you're charging a capacitor through a resistor. And the op amp is there to make sure it happens linearly. So it's not just like a random curve or it's just a straight line going down. And because you're applying power to a resistor heats up. And at a certain point, you're at a level of precision where that resistor heating itself up causes your measurement to change. So you have to make sure it's a low amount of current. It's like you're basically juggling 20 different physical effects. Like that's why if you notice, like on the PCB, you see how it's cut out. It's
let's
like on
go
a
back full screen.
yeah. You can see that like that's actually transparent. You can see my eye through it.
Yeah, you're right.
That's like a thermal cutout because the chip here
Okay.
is so sensitive that the heating of this one will change your measurement.
Got it.
And hopefully, by the time you've juggled enough of these around, it works. And you because it could be that it's not linear in its response. Like instead of having like, how do I put this? You have like whatever your input is, and you have like a data output. You want it to always be the same. God damn it, that's the dumbest way I've ever thought of phrasing it. Basically, for you want it so that for every input you have a defined output,
Okay.
and you want the difference to be the same. So like if at 0 volts input you've got an error of 0.1 volts, you want that error to be consistent because then you can just subtract the error.
Sure.
And that's what makes it so difficult to actually get it to be precise, is to make sure that the error is consistent.
Got it. And it's not changing either with time or with input voltage.
Exactly. Which is why it costs so much for. Remember, in my previous time on this show, I mentioned a chip that's been around for 40 years, and it's been the kind of the staple in these types of measurements.
Yeah.
The reason that was the staple is because it was so stable over time.
Got it.
It would change by about 4 millionths of like its normal kind of thing, for 4 parts per million.
Yeah.
Over about of the first year of its life.
Got it.
And then it would stay solid for the rest of it.
Yeah.
So it wouldn't change. So your measurements would almost always be consistent.
Yeah.
Which is why the designs like the 3458A that I mentioned as well from Keysight still exists. Because it's like,
it's sort of this known quantity that is very stable.
It's like it works.
Yeah.
It still works. And it's
let's go back to this comparator circuit again, because I do want to understand this. So walk us through this circuit again. So
this is the integrator. This is like the most basic component of the whole thing. And what it does is it's trying to, like, with any op amp, it's trying to match the inputs so that they're the same. One input is ground. The other input needs to be ground. So when you put current in, the voltage goes up.
Yep.
All of a sudden, there's a difference. Now the op amp has to compensate. But the feedback is a capacitor. It's not a DC path. So you're not going to get a DC voltage from it.
Right.
So the only way to be able to make sure that it cancels out that current is by constantly having a changing voltage.
Okay.
So for those people who know, capacitors only let through AC.
Right.
If it's a constant signal, it doesn't let anything through.
Yes.
If it's a changing signal, it lets it through.
Yep.
So to have a constant current, you need a constantly changing voltage, and that voltage ends up being just a straight line.
I see.
Actually, I don't know. Am I able to share my screen? Because this
I think so. Go for it.
Do I do
Behave, but go for it.
Then I should have closed some tabs here that might be incriminating.
Yeah. I found it's better to share a single tab if.
I thought you were about to say share incriminating evidence. How do I do that? Share screen? Do we get to? Okay, here we go. Share.
And then we'll bring you on here. Okay. So let's turn this one off. Are you ready for me to share that?
Yeah, I believe so. I hope so.
Okay.
So yeah, that's visible. Perfect.
Yeah.
So if I grab, this is Falstad, by the way. I can probably post a link about it, but it's a really cool kind of tool that I found for simulating.
This is awesome because my analog experience is quite limited, so this is useful learning.
Yeah. This wouldn't be something you'd generally get in like an undergraduate course, unless you've got spare time. So if I grab.
And so this is a simulator?
Yeah, it's like
Yep.
a bare bones. I have an idea. I want it to be kind of checked, basically.
And it's called Fallstad?
Yeah, I'm going to post a link for it in the
cool.
electronics part of the Discord.
Yep. Maybe post it. Maybe if we can post it in Twitch too, just for people who are watching right now.
Where's Twitch? Will I be able to post the link?
I think you can. Yeah, Sahko's got you. We got it.
Perfect.
Yep.
So do shit. So this is the basic thing, right? I've got random voltage in, random resistor, random thing. And you can see the actual curve here. So if I check the curve there, that's the input. It's always 0. But the output is just a straight line.
From 5 volts to 0 volts?
From 0 to minus 50, or minus whatever the, say plus minus 5 is the range.
Okay.
So it goes to minus 15 or whatever.
Yep.
If I reset that and run it, you can see it goes down. And once it reaches its limit, it can't keep that stable. So then the input starts rising back. But this kind of so if I then do a negative voltage here and reset it, now it goes up.
Got it.
And that's basically the property you're trying to exploit.
Got it. And so you're measuring how long it takes. So which of these signals, the -5 you've got right now is your measurement?
Yeah.
Is the voltage you're measuring?
Yes.
And then where is your reference voltage?
Into the same place. So if you'd normally have God damn it. This is the one thing I hate about this is the interface is kind of ass. You'd have a set of...
That's true for all electronics tools these days. Or at least all free ones.
Hold on, where are they? Because there's 2 different types of switches you can pull in this thing, which is really annoying. Here we go. So to get your reference in, you'd have like probably at minimum 3 different
oh, I get it. Right. I remember
switches.
Yep.
So if I find where the sources are again.
This is instructive.
5, say 5. So say if you've got 2.5 volts on the input, you would be there. So, yeah, that's now 0. It's auto ranging. So if I just
God,
I'm not screwing with that anyway. So if I just apply the signal for some random amount of time, there it goes down and it stays there. Because now now there's nothing on the input. The input is 0, so it doesn't have to compensate for it.
Yep.
But it's already charged the capacitor a bit, so it's going to hold it.
Okay.
It won't hold it perfectly in the real world.
Sure.
But for now, that's good enough. So now to bring that back to 0 to actually measure it, you use the opposite polarity, and then it brings it back. And so you can then see, if I stop it, like how long that took.
How long that took to come back up. I got it.
Yeah.
That makes sense.
You can do the maths, but I think that's, if it makes sense, it makes sense.
Yeah.
It would have been probably whatever, like half the time, for example, to bring it back than it did to bring it up. So you can tell that whatever the reference is twice the input.
Right.
And then if you know the reference, then you can just do basic maths and get the input. And you can do
and so you're comparing the time of how long it took to get to a stable state when you were using the reference or using the measurement voltage versus the reference. You're comparing the time between the two.
You're because like you always sample the input for a specific amount of time.
Yep.
It's always the same. Yep. Say 1 millisecond, as I mentioned before. That will bring it to a.
And then how long it takes to bring it back to 0 is your measurement.
Yes, because the actual voltage. Yeah, because the actual voltage this ends at. So if I tap it there, that voltage there that it gets to in your arbitrary amount of time, it doesn't matter.
Right.
Like it
It's
actually
how
doesn't.
long it takes it to bring it back to the original voltage.
Because that way you're removing the actual voltage from the equation. It's just time and
just
a
time.
reference.
Yep. Got it.
But if you start looking into like the more advanced ways of, because like you can only charge it for so long. So if I just take it and hold it, you can see it stops.
Right.
Because all of a sudden, like the op amp is saturated. There's not enough. There's nowhere to go.
Yep.
There's no higher voltage that it can go to.
Right.
So what you can do is you can actually, while you're charging this, you can also discharge it a bit and kind of go back and forth and back and forth and switch random references, random different signals, and just build a better kind of idea of what your input is.
Yep.
So this is
that's
actually
what gives you more time slices, essentially.
Yeah.
More granular time slices. Interesting. Yeah. And so then where is the output of this to the digital part of your circuit?
You would have a comparator. Well, you'd have an amplifier first, but because this is a simulation, I can just put it directly into a comparator.
Yep.
Then that goes to your digital output, whatever it happens to be, like a lamp, I guess.
Okay.
So if I do something with this there, so when it crosses it, that's all that matters, basically.
I see. So just crossing zero.
Yeah.
Yeah, got it.
It's about the worst possible, the least intuitive way I could have explained it, but when you've got just this to work with, it kind of. Sure, wait, can I just do this? Yeah. You can graph it using the wires.
Oh, there you go.
So if you've got your random, like you charge for, pretend that's the letter T.
Okay.
For a random amount of time. That's just sample time. Yep. It gets to a random voltage, and then you just use your reference, which you always know what the reference is, to discharge it.
I'm sure those are very, very precise and accurate.
Yeah, hopefully. if you get it right, hopefully. So then you've got this other...
Yeah, that's the goal.
Yeah. See, you've discharged it, and then you've got this arbitrary amount of time.
Yep.
There.
And then you're using the second comparator to just measure
when it gets back to zero.
When it crosses zero. Yeah.
Yeah, or when it gets back to like when you finally discharge it. So the ratio between these two times is the ratio between your reference and your input. Your reference is known. Now your input is known.
Yep.
But with this the 3450, the 3458A does it slightly differently. It uses a similar thing where it would charge a capacitor, but instead of just discharging it like with one slope, we should call it, it uses multiple slopes, which is why it's called a multi-slope converter. Okay. So it actually has a very sharp slope that goes straight down, well, almost straight down. And then it has a smaller one that goes slightly up, and then an even smaller one that goes slightly down, and then eventually it gets to zero. And that, for some reason, that connecting that wire broke the software. So that's how.
I mean, don't you lose a lot of accuracy in that first nearly vertical slope?
No. This is actually used to get more accuracy. So it's not. This isn't actually vertical. It's just that it can't actually there. It's just sharp.
Okay.
You get your limit. You get your resolution from this, and then you get slightly more resolution from the smaller slope, and the further you go along, because like obviously the comparator.
Oh, this makes sense now. Yeah. So you're let's say you're taking your first digit from that first slope. So you know. What's the kind of order of magnitude of this signal, of this voltage? And then you're using, so basically you're as long as you can accurately measure as long as that first slope is of its sort of known quantity, if you're subtracting off a known number of volts,
Yeah.
then you can use, you can essentially sort of pick up your remainder on the rest of them. Is that right?
Exactly. So because there's a bit of overshoot, which is like your minimum sample time, like the smallest
Yep.
time you can sample, you're using the smaller slope to get the remainder. But then you keep getting
I get it now.
the remainder, and it goes down to like a finer and finer amount.
Got it.
And so to do
That
this, you'd
makes a
have
ton
like
of sense.
you just have, instead of having this like 2 rank of, you just have one resistor.
Yep.
And now instead you'll be switching. Delete this wire for some reason. Anyway, pretend this is not here, but you'll actually have different resistances now.
Right.
And so in mine it'll be like 10K.
That are giving you different amount of current flow for charging that capacitor.
And it's smaller and smaller and smaller until it gets like into the meg ohm.
Right. Okay.
And
this
that
makes
causes
sense.
it to be slower.
So essentially,
slower
like,
charging.
let's say your first big drop, let's say you have a signal that's 5.123, right? Your first drop, let's say you subtract off 6 volts, and you know very precisely that it's going to be 6 volts, but you don't know what the remainder is. Still, you know that it's somewhere between 5 and 6, right, from that first slope. Do you get that level of accuracy? Because you've gone through, let's say you have 1 clock tick per volt. You have, you've gone between 5 and somewhere between your 5th and your 6th tick, you cross 0.
Yeah, it's a good way of thinking about it. Yeah, like, so you're basically just,
and then the next time you then take it slower, right? So the first time is very, very fast, and then the second time is a bit slower, and okay, well, we crossed the threshold, somewhere between 1 and 2 ticks. So that's, 0.1. And I know the math on this is very, very simplified, but, we cross the threshold again, somewhere between 1 and 2 clock ticks. And now, okay, we go for our next digit, which is even slower. It's an order of magnitude slower. And now we know, okay, it was between 2 and 3 clock ticks. So now we've got 5.12. Am I explaining this right?
More or less, yeah. Like you're slowly trying to get a finer and finer idea of what it is you're actually measuring. And so this
by
is actually
using less and less current over time.
Yes.
But I think the implication for this is that your clock ticks have to be incredibly precise, right? Because that initial slope, your initial subtraction of 6 volts has to be accurate to your final number of decimal places.
The clock actually stays the same the whole time.
No, I know, but that clock tick has to be extremely precise. So that
not really, actually. As long as it stays the same, you don't you don't even need to know what the clock actually is.
Correct. Right. But it needs to not drift at all over time.
Yeah.
Yeah.
But even if it does, if it drifts over the course of, say, a month or something.
Right, that shouldn't matter.
It can drift by 20%.
Yep.
But because your measurement is only lasting, say, 50 seconds.
Yeah, it needs to be consistent from tick to tick.
Yeah.
It needs to be incredibly consistent from tick to tick.
Because even like the cheapest clocks, like the cheapest oscillators, have very low jitter. That's what you'd be looking for, is jitter, like clock to clock variations. But that it gets to a point where it's like it's not even a consideration. It's like, we have a clock.
Okay.
What's available in the market? Yeah, I should get that. Good enough.
Yeah, right.
So even in something like the 3458A, it's the cheapest chip's clock.
Yeah, interesting.
Yeah, and
interesting. Well, this is super cool. Yeah, I didn't.
Yeah, there's far more to it, but I think people are starting to doze off. So.
Yeah. Well, awesome. Well, thanks for sharing this. I feel smarter for knowing this now. Is this the way I've got like a handheld Keysight multimeter? Is this the way one of those would work as well?
Maybe.
Okay.
There are other ways to have an ADC. Like an oscilloscope, for example, would have what's called a flash ADC, which just compares a bunch of it just has like a couple hundred or 1,000 comparators and every single voltage step is checked.
I see.
And that's the fastest way, to some extent, you can do that.
Right.
Because you're
You
basically
need to be able to do it very, very quickly.
you need to know it like at any moment in time, because you're running
Yeah.
at a couple of megahertz, gigahertz.
Yeah.
And for the most part, besides like ones like that, like the flash ADC, they are all based off turning a voltage into some sort of time. There's delta sigma ADCs, there's successive approximation, which is I'm gonna go into it a tiny bit, but it's actually kind of cool the way it works.
Everybody seems to be enjoying this. I think we are losing a few viewers, but the people that are here are enjoying it. Everybody's saying this would be a perfect YouTube video, which has been seconded. So
if I had the time to actually prepare something,
maybe once you finish your project here.
If I had the time to actually prepare something, it would have been a lot more coherent and interesting.
Yeah.
But me blabbering on for 45 minutes.
I'm interested, and other people seem to be interested. So apparently, viewers are going up over the long time period here. So let's keep going.
Cool.
As if you're up for it, I'm learning stuff. So
I might as well then talk about this one then.
Yeah, please.
So this would be.
Let's back up. I will finally admit my knowledge of comparators is less than it should be, and I know you gave a rudimentary explanation at the beginning, but I wonder if there are a bunch of other people that need more of an explanation. Can you do a brief couple-minute intro into comparators?
Op-amps or comparators?
Oh, op-amps, sorry.
Yeah. Well, the way you explained it in...
Yeah, maybe both.
They're actually the same thing.
Yeah.
So that's step number one, is comparators and op-amps are the same thing.
Yeah.
Just a comparator.
Comparators are a specific way of wiring up an op-amp, right?
Yeah.
Yeah.
But the basics of an op-amp is, you see, you've got two inputs. You've got a non-inverting and inverting. Let's call them plus and minus.
Okay.
So the first thing that happens...
Inverting would be minus and non-inverting would be plus?
Yeah.
Okay.
So the first thing that happens is you get... God damn it, there has to be a way of drawing on this, doesn't it? Screw it. So I'm going to continue using these...
Sure. It seems to be working. People are really appreciating the visuals, so...
I need visuals. Yeah. If I don't have visuals...
Please keep going.
I'm going to screw up. But anyway, so the first thing that happens... There's three basic stages. The first one is you get your two inputs, and you subtract the positive one from the negative one.
Okay.
And pretend this is in brackets, because otherwise it's just another minus or whatever.
Yep.
So that's your differential input.
And these are voltages, right? So you're subtracting...
Yeah. There are ways to do it with current, but for the most part, any op-amp you get off the shelf uses voltage. I just spotted a whiteboard to my left, but I think that's a bit much.
Yeah, I think
so the first stage is the differential input, it's called. It's a differential amplifier.
Yep.
It gets the difference between the input and the other input. Then that goes into a voltage amplifier, which could just be... Is there text mode? There is probably...
Yeah, you're getting lots of kudos in the chat here. Super interesting. I'm not so familiar with electronics, and he's really good at explaining, and I even get some understanding of how this works. So keep going.
Yeah. I legit have had to go up after a lecture at one point to then explain to my friends and stuff how stuff works. Because otherwise, because the lectures in the academic... Yeah, because like the academic mindset of this is how it is. Remember it or not, I don't care.
Yeah.
But anyway, yeah.
Particularly research professors who just want to do their research, and they have to teach a certain number of classes a year, and they just do not care.
God, I hate that so much. Anyway, so you've got your differential input now. You know the difference between the two inputs. Then you add gain, which in an op-amp could be 1 million, 10 million. It actually doesn't really matter.
Yep.
The higher, the better.
And this is just how much are we multiplying the difference of the two inputs?
Yeah. So like, if I actually go back to this kind of equation type way of thinking about it, might be actually easier. You then multiply that by, say, 1 million, for example.
Okay.
Now you've got just what is basically like any tiny difference will send the op amp to either max out the output or to minimize the output.
Okay.
The final stage then is just a power amplifier. And I don't know if you're kind of thinking about it or if I'm just explaining.
No, I'm just trying to figure out when you say the final stage is a power amplifier, are there 2 amplification steps or just the one?
2. There's a voltage
2,
amplifier,
okay.
and then you can think of it as a current amplifier.
Okay.
Just to make the output kind of worthy of doing anything.
Right. Okay. So that you can drive it. It has enough current that you can drive another circuit with it.
So yeah, so now you've basically all you've done is you've amplified the difference between the inputs.
Got it. Okay. Yep.
And
presumably you can get op amps that have a much lower amplification as well, right?
Yes, but there's no need to.
Right. Okay.
Because the way you then tame, well, actually, I can even do it visually as well because I can actually add voltages.
Yeah.
So if I got, software is really struggling with these graphs. There you go. Yeah, there. So I should be able to just double click on this. Yeah, show voltage.
Probably just simulate it. Yeah.
Yeah. That's what I'm talking about. So okay,
Yeah.
if I do 5.01.
Got it.
That's probably far too much. Even like 1 millivolt, it's immediately maxed out.
Right.
Because I have no feedback. This is an open loop configuration. That's what you'd call this, an open loop.
Yep.
Because there's no feedback or anything. If I now go and actually add some feedback. So for example, like one input, yeah, see there? So now you've actually tied the output to an input.
Yep.
And it's trying to, like, the only way to make the output of this stable is if the inputs are the same.
The inputs are the same.
Yeah.
Oh, I see. Exactly the same. Yeah, I get it.
Yeah. So if I actually show voltage here. There, see? So to make the inputs the same, has to do something to the output.
Right, because this thing has such high gain on the amplifier that if there's any difference between the inputs, it's going to either drive it to 0 or drive it to max voltage.
Exactly. So it's trying to find a way to not do that, basically.
Yep.
So in this configuration, you've got a non-inverting amplifier. The output is divided by 2 because of the resistor divider.
Yeah, so we should explain that real quick, just to people who aren't electronics folks. A voltage divider is where you've got 2 resistors between. Yeah.
I can do it this way.
And this is a super common building block for a whole bunch of things.
Yeah. So so you're basically like you've divided the voltage. So it's 5 divided by.
So and it's based on the ratio of the resistance of the 2 resistors.
Yeah. So if I set this
the
to
same,
9,
then it cuts it in half.
It should be 90%.
Right.
If I do this to 0.9, I think. Nope, never mind. Okay. Anyway, it's annoying to think about it properly, but anyway, just say this divided by 2.
Yeah. And so this is often used for, like, if you want a voltage of a specific, you have 5 volts and you have ground and you want to get 3 volts out, you can pick your resistors accordingly to get 3 volts.
Yeah. But for now, you can just think about this as a box that divides the signal by 2. Oh,
yep.
This fucking thing's broken.
It doesn't really want you to be doing things the way you're doing.
I didn't even delete it. There we go.
Yeah.
Set. Someone's JavaScript final year project is breaking. There we go.
Yeah.
So they say, okay, so one input is just 5 volts.
Yep.
One input is actually the output divided by 2.
Got it.
To make them the same, you need to do something to the output to make the other input 5 volts. Well, the input is just the output divided by 2. So the input has to be multiplied by 2 to give you the output.
Got it.
Which, well, there's a bit of error here, but
Sure.
it's 10 volts.
Yep.
So now you've just multiplied it by 10 volts, or by 2, to get you 10.
Got it. Yes.
So if I actually screw around with the ratio, I can,
You can get any
say, 9.
output voltage you want.
But now we've run into the limit of the op amp. If I just remove the limit, there. Now that ratio gives you divide by 10, which gives an output multiplied by 10.
This is awesome. This is something I took a couple electronic courses in college, but we didn't actually get into op amps. So this is awesome.
Yeah, there's far more to get into than this.
Yeah,
but hopefully that was a good way to start someone off on the right path.
Yeah, I think that's a pretty good explanation. If folks that are watching have questions, fire away in the chat here, and we'll try and answer them.
Well, let me try open the chat.
Yeah, I don't see any right now.
Either I'm so good that nobody asks questions, or I'm so bad no one even knows what to ask about.
I think this is making sense to folks. Yeah, I think this is making sense. Okay, so we understand how op amps are used now, and how they're used as a comparator. So you were going to then explain a different kind of ADC here.
Yeah, it's the one I'm talking about is successive approximation.
Okay.
I don't know what the OR stands for, but something. It's successive approximation something. I can't remember. But there's something I don't think matters enough to be remembered.
Yeah.
But this one is actually kind of interesting because it has a DAC in it as well, it has a DAC. So it's converting an analog signal to a digital signal by also converting a digital one to an analog one.
Okay.
Someone is asking what a physical op amp looks like. It's just a chip.
Yeah, it would be a chip. It would look like it could look like one of these chips here that I was showing off earlier.
Yeah.
Right.
So it could look like one like that might have 4 in it or something.
Right. Exactly.
It's very conventional.
This is on the big side, but yeah, it's common to have packages like this that have multiple of a building block in them. They might have an op amp or an AND gate or something like that. They might have 2 or 4 or whatever.
Yeah. So one quick kind of back to how a comparator works.
Yeah.
Yes, someone's mentioned successive approximation register, but the register part is kind of just a technical term that has to be tacked on for whatever reason. Probably just to make sure the patent goes through.
So, I have an idea of how this might work, but I'm very curious to see.
It's probably correct because it's a very kind of simple, and it's one of those things that you'd think it wouldn't really work that well.
Can I guess at it then?
I'll give you that in a second, but I just want to explain this.
All right, go ahead.
So a comparator is basically an op amp without feedback. You've got your reference, which in this case is just ground, because you want to see if something's above or below ground.
Okay, sure.
And because you've got that infinite gain, if it's a tiny bit above ground, you've got your output.
Yep.
And
then you could feed that into some
into whatever you want.
But you can. My point was that you could flip some digital gate with that at that point.
Yeah. And that's exactly what I'm doing with my one.
Because it's essentially amplifying it to the point that it will flip a digital gate. The problem being that, let's say your input was 0.1 volts. That's not high enough to flip a digital gate on any circuitry. So you need sort of the gain and the current to flip the gate.
Yeah. So say if you've got a chip or whatever that takes a 5-volt input.
Yeah.
All you have to do is make sure that output doesn't go beyond 5 volts.
Right.
All of a sudden you can go from.
But I guess the point that I'm making for people who don't know as much as you is that digital gates have a threshold for what they consider a positive signal, and that's actually it could be potentially quite high compared to your input signal that you want to measure, right?
Yeah.
So you might have to hit 3.3 volts for it to consider it high. Otherwise, it'll consider it low. And so this essentially gives you the amplification you need to measure that.
Yeah, basically. What was I saying? But yeah,
you were saying comparator.
Yeah, if it goes below 0, it multiplies the difference, whatever it happens to be, by as much as it can, and then output. So it's like
Yep.
below 0, -5, because that's what the output is limited to.
Yeah.
Above 0, 5. And you can just use that. And like commercial comparators actually have 2 power supplies. So they have the input, and then they have a digital supply output. Because some things might not be able to take voltage, whatever. It's like it's easier to get the right range.
Yeah.
So the way this successive approximation register, now that I know that.
So can I guess at it?
Yeah, sure.
Okay, so what I would do is I would say you would. Well, I was going on the previous design. So take the previous design and have your digital to analog converter be your reference voltage. And then you can quickly change reference voltages by driving your DAC.
That's close.
Okay.
And for the most part, correct. But there's no kind of relation between this one and the previous one.
Oh, okay.
Because there's no need to.
Okay.
Because like the time factor is kind of gone now. If you're changing your reference, the time doesn't matter.
Okay.
So now what you do instead is you have this going to some digital input somewhere.
Okay.
And you have your varying reference voltage.
Yep. From your DAC, which is a digital to analog converter. So it's basically you can send it digital information and it will output a voltage.
Yeah. Of whatever you want.
Yeah.
So say if you've got varying voltage. 1.2 or whatever, 1.234 volts in for whatever reason. And you've got your DAC initially set to 0. Your kind of reference set to 0. It's like, okay, right, how, like, so now we need to find out what this input is. Yep. Well, is it greater than or less than 2? Okay, it's less than 2. Is it greater than or less than 1? It's greater than 1.5. Still less. 1.
Okay.
1.
And then so you can essentially do a binary search on this now.
Exactly. It's like a binary. It's like, well, now you need to know what a binary search is.
Yes, so we can explain that too.
Yeah, you're getting closer and closer. It's like, okay, right, it's still less than 1.25. Say 1.2.
So,
no.
So this requires having a very accurate DAC.
Exactly. Which is why these can only get so accurate.
I see.
But at some point, you get close enough. It's very fast, thankfully.
Yep.
Someone's mentioned bisection method. You can think of it that way. You're just getting closer and closer and closer to what the actual value is.
Binary search eventually would be the computer science word for a bisection method here. So
yeah. So eventually you get close enough to to your unknown input. Well, you know what like bits you had to send to generate this output.
Yep.
So there you go. You've got your input because this is now 0.
So you can just gradually move your, essentially if you've got bounds, you're like, well, it's more than this and it's less than this. It's somewhere in between here. You can just move those bounds closer and closer and closer until you're at the limit of your resolution of your
measurement. And so now your only limit is the resolution of the DAC.
Yep. And I guess the accuracy of your op amp.
Yeah. But that'll
be probably characterize that and null that out.
Yeah, which is another interesting thing because there's various effects. These actually won't be the same.
Right.
They'll be close.
Yep.
And generally close enough. But then you get into the fact that the error will always be the same.
Right, and then you can just subtract that error out.
Yeah. So it could be a case of you put in 0 and you think it should be 0, but it won't be. It'll be like 0.0001 or something.
Yeah.
Or whatever.
And is that usually a linear relationship? So it's pretty easy to null out, or you have to build a characterization curve?
In most op amps, most kind of just generic ones, it's not linear.
Yeah.
But when you get into the precision ones and the more expensive, like a $10 op amp, then it starts to be more linear, more predictable.
Yeah.
Because it's less about it being.
So NextFX is asking, is this how digital voltage meters work? And yes. That's what.
Yeah,
That's
it's one
essentially
way
what we're
that
talking
they
about
can
here.
work.
Yeah.
Like, because it's just a voltmeter is literally just an analog to digital converter and a display.
Yeah. And so is this what you would see in like a multimeter you buy kind of off the shelf, a handheld, mid or low
Depends on how
range?
much you pay for it.
Yeah.
Yeah, probably. If you buy one
Okay.
at, like, as the guy suggested, Home Depot, it's probably using what's called the Delta Sigma ADC,
Okay.
which I'm not too well versed in
Yeah.
because it's a bit more kind of.
And would that be less or more accurate than what we just described here?
They'd be fairly similar.
Okay.
But yeah, like the Delta Sigma one is another one that works with time and shifting that around and kind of.
Yeah.
Like the way a Delta Sigma one works is it actually, instead of outputting a number like a byte or a couple bytes of data, it actually outputs a clock, I think, if I'm
Oh,
correct.
okay.
Like a
Interesting.
series of
Pulses.
of pulses in a way.
Interesting.
And then you can measure that pretty easily to
Yeah.
figure out what's up. And then you can filter that to get better and better resolution. And you go
Right.
into a lot of like digital signal processing. And don't hold me to the Delta Sigma because I'm not 100% sure about it.
Okay.
But I believe that's how it works.
And so, we've talked through some of these circuits. What considerations are you having to make to get to your 8.5 digits, your 28 bits?
The main one is self-heating.
Okay.
Components get warm
As
from
you're running
doing work.
current through these things, they're heating up.
Yeah. And it creates a tiny, tiny difference.
Yeah.
It's normally called a power coefficient or something. There's loads of different names for it. But basically, you feed 10 volts into a 10K resistor, that resistor will not stay at 10K.
I see. Does
So
it go
now
up or
all of a
down
sudden-
usually?
It's whichever
sure.
way it goes, it goes.
Okay.
It's kind of, it's because it's an undesired kind of more or less random effect.
Yeah.
It can go up, it can go down.
Okay.
Hopefully, it goes the same way every time.
Right.
But basically, then all of a sudden, for different inputs, you have another parameter to worry about.
Right.
If the input's always the same, you don't have to worry about it because the heating is always the same.
Yeah. And so is there a warm-up period for these
Yes.
devices of this accuracy where you kind of let them warm up before you can get an accurate measurement?
Yeah. Yeah. Like, if you're trying to use the aforementioned 3458A, if you want to calibrate it, it's going to have to sit on a bench for 24 hours, I think, minimum, before they will even look at it.
And is this plugged in and on?
Yes. This is like,
Okay.
This is plugged in and on. So the 3458As we have in analog devices, or you would have in any sort of calibration lab,
Yeah.
or for the most part anywhere where you would have one, they would be on permanently.
Oh.
There are ones in the California, or not California, I think it's both the California and the Texas branch of analog devices that have been on for, I believe, 35 or 36 years.
Wow.
Without ever having been turned off.
And so they're like
Just
on a
there.
UPS or something where, and that's just to maintain temperature.
It's to maintain a lot of things, but for the most part, internal temperature and stability.
Yeah. Wow. That's
and then
incredible.
you have what happened at some point in the middle of last year, where the UPS failed. So, at one point, again referring to the previous time I was on, I mentioned a part that's not out yet. It is publicly known about, but it's not out yet.
Yeah.
It was being measured, and it has to be measured for literally for a year solid without ever stopping, just to get the characteristic curve.
Yeah.
And so you can see it kind of it does its initial kind of drift, and it starts to level out, and then it's just a bunch of messiness as the UPS dies, and then it goes straight again.
Oh.
And so about literally a year. You can't speed this up. This is
No.
real data. A year worth of real data gone. And so the part was delayed by
one
a
test
year.
setup.
No, they had like 8 of these, but they were all on one UPS.
Oh, that's a fail. That's a design failure.
It's a very bad fail.
We've got a question from the chat here. Could you measure voltage somehow in a different way, in a similar way as a digital quartz clock counts time? Some sort of logic gates that flip at regular intervals when your capacitor discharges.
I believe that's what delta sigma ADC actually is.
Okay.
Instead of having like a particular reference that gets fed in and out, it's just a clock that gets like a reference clock that gets fed in and out. And I believe that's close to actually how it works.
Yep.
This people is what we call a single point of failure.
Yep.
Yeah.
Yeah. And unfortunately,
so this part,
no matter how much planning you do, there's often, with sufficiently large systems, you discover that you have a single point of failure where you didn't think you had one.
Yeah.
Or where you didn't think to look.
One of my kind of best friends at the company, who's currently there, because I'm not working there at the moment. I'll be back there in a few months. He's asked me to stop talking about this chip, or to stop, to him specifically. He doesn't care if I talked about it anywhere else, but to him specifically, because he's just gotten annoyed at it.
Yeah.
But it's like, I think the chip was delayed by a year, and there are probably other reasons, but I believe the reason was that UPS snafu. Because now they have to recapture all the data. Because this is data that is like the reason this thing exists.
Right. So you can't use this chip unless you have this characterization data.
Basically. But you can, but good luck relying on it.
Oh, I see. Right. Okay. Yeah. This is sort of your guarantee of accuracy over time. Yeah.
Yes.
Well, Alex, this has been amazing. Thank you. Thank you for the impromptu lesson in op amps, and
clap real quick to make sure everyone wakes back up.
Yeah. It's good to understand a bit more of what the challenges you're facing with this project are. So I'm excited to see where it goes. Will you come back on once you get it working?
Yes, definitely.
Well, it sounds like you have to get it working if you're going to graduate here.
I have to get it working by like April.
Yeah.
If it works or not isn't the biggest issue. It's the fact that I have to do a report on it.
Yeah. Right. Fair enough.
And with what my supervisor is telling me, the amount of crap I'm going to have to include in that report, it's going to be like a 50, 60 page report.
Yeah. Yeah. Well, welcome to academia, right?
I can't wait till I'm graduated. If I graduate.
I was the same way when I was a senior in my CS degree. Let me out of here. I am done with the academic research writing portion of this experience.
My main problem right now is the fact that I got a taste of industry, and I want to get back. Yeah. I want to be able to afford to go places.
I was the same way. Well, thank you again, and we'll see you on a future one once you get it working.
Perfect.
All right. Have a good evening.
Thank you.
Oh, that was awesome. That was fantastic. I hope you all enjoyed that as much as I did. That was really awesome. We've run a fair bit over time. I was planning on just running 2 hours, but that was so interesting that it was worth extending for. So thank you all for sticking around. That was stellar. We might have to do some more kind of learning sessions like this, because I know a fair amount of folks that could teach us some cool stuff. So this is definitely worth repeating, I think. I think with that, we'll kind of wrap things up here. I'm definitely going to have to go check out Falstad. Like I said, I have kind of limited background in analog, so playing with a simulator like this would be awesome. So hearing please more lectures. So let's maybe figure out how to supplement kind of show and tell with some lectures here. Like we said before, if you've joined since then, we'd love to have you on show and tell. You don't have to be an expert like Sahko is. We really welcome everybody to show off what they're working on, or if you've got something cool you bought, or you've got a cool workspace you want to show off. You're more than welcome. So this is the link to sign up, and we'll get you on next time here. And then, of course, come hang out with us in the Discord. That's Sahko's a regular there. A lot of the folks in the chat, obviously the mods. Huge thank you to DG Marlis and Scave Rat and Nosh, but graphics gear is the handle he's currently working under. Huge thank you to them for moderating and making this run so smoothly behind the scenes. They're doing a fair amount to make sure there are images for me to bring up and helping guests come on and as well as just moderating chat and that sort of thing. They also moderate the Discord. So come hang out with us. There are tons of people who are talking about other exciting projects and getting help with things and asking questions and learning and sharing. So I'm there on a regular basis. I've been a little quiet the past 2 days because I've been fighting fires, but I'm always in there and paying attention. Yeah. And, I mentioned this at the beginning, but just a quick shout out. If you'd like to support Strange Parts, the best way to do it is through the Patreon. So patreon.com/strangeparts. You can get all sorts of cool behind the scenes updates and see videos while we're still editing them and give input on what I work on next, as well as things like design files for digital design files for projects I make, as well as merch. T-shirts and hoodies are coming out soon. So if you are a Patreon subscriber, I've got an update about those that I'll share on Patreon here today or tomorrow. Appreciate everybody for tuning in and hanging out and all the support. And I'll see you all on the Discord. Have a good rest of your weekend and take care. I'll see you again soon.